Okay guys, so I decided to record this to help you out on your homework. So since I'm technically not here, I'm only here in this virtual world, I'm going to show you how to do a few of these. There's especially a couple of these that could be a little confusing, right? So again, this is for Thursday. So if you weren't here the day before, which I did have a lot of people absent, right? We did something called, let me start off with this one actually. So I'm going to start with this one, 7-4, right? So in this one we're using the method of elimination. Alright, so we're trying to eliminate. So again, for the people that weren't here, what we do here, I'm going to start with number 2 and I'll go back to this one. What we can do here is that if we add this equation and this equation, alright, eliminating means that when I add them together, if I add this equation and that equation, one of the variables is going to cancel. Alright, so notice that if I add 2x minus 2x, that's 0x. Alright, so this cancels out. Right. However, if I add 2y and y, that's going to give me a 3y, and this is going to be equal to 12. Okay, so that's going to be 3y is equal to 12. So at that point, I'm going to solve for y. So I'm going to divide both sides by 3. So I'm going to get y is equal to 4. Like that. Okay. Now, once I get one of the variables, then what I can do is I'm going to go back over here. I'm going to plug in y is equal to 4 into one of the equations. And by one of the equations, I mean one of the equations that you see above you here. So one of those two. Right? It doesn't matter really which one you pick. I'm going to pick the top one. So I have 2x plus 2. Now instead of y, I'm going to plug in that 4 that I came up with. Okay, so that's, that's 2 times 4 is equal to 2. And then now I'm just going to multiply here. So I have 2x plus 8 is equal to 2. Then I'm going to subtract 8 from both sides. So I get 2x is equal to negative 6. And then when I divide both sides by 2, I get x is equal to negative 3. Alright, so this is part of the answer, this is the other part of the answer. Don't forget that in general when we're doing this, alright, the answer is a coordinate point, negative 3, 4. So remember that this point right here is the point of intersection, alright? We're just doing it a different way, but after all, this is the point where these two lines intersect. Excuse me. Now in the very next one, I'm going to do this one right here. So if we're still doing elimination process here. So notice that right here, if I try to add this together as they are, nothing is going to cancel. That's going to give me a negative x, that's going to give me a 2y. So one of the variables has to cancel. So what I can do is I can multiply this one. Let me do something different. Maybe you already see that this is going to cancel out, right? You have, if I make this a negative, I'll have y minus y, so maybe that's easier. But there's going to be some times where you can't do that. And I'll give you an example of that here in just a second. However, I'm going to go ahead and try to get rid of the x again just for practice. So what I'm going to do here is I'm going to multiply every one of these terms times 2. Alright, and when I do that, I would recommend rewriting it. Alright, that stays the same, but this part on the bottom I would have 2x plus 2y is equal to 10. Alright, again I multiplied each one of these terms by 2. Now I can add them together. Now if I add this and this, notice that's going to cancel. Right? And this is going to be 3y, and this is going to be 9. Right? Then I'm going to solve for y here. So divide both sides by 3, so I get y is equal to 3. Right? So again, how do I know what number to multiply here? Well, I'm multiplying times a number that would cancel either the x or the y when I add them together. Alright, so in this case, I wanted to cancel the x, so I multiplied times a positive 2 because I knew that if I add negative 2 plus 2, that would cancel this out. Alright, so then again, I would grab that 3 right there, and I'm going to plug that back into this one of these two original equations. Alright, I'm going to choose this one right here. Before I change anything, this used to be x plus y is equal to 5. Alright, so I'm going to plug in a 3 here, so I have x plus 3 is equal to 5. And if I subtract 3 from each side, I get x is equal to 2. Alright, so that's the other part of the answer. So again, the coordinate point would be 2, 3. Alright, again, this is called elimination. Now, I'm going to do a couple here that are different enough that I may mess you up. Okay, so for example, notice that on this one, if I add them like they are, again, nothing's going to cancel. So what I'm going to do here is I'm going to multiply the top part. It's going to be kind of hard to do in this little amount of space. Times -2, right? So I'm multiplying all of these times a -2. And I'm going to rewrite them so I can figure that out better. So -2 times -x will make that a positive 2x. -2 times y will make that a -2y. And then -2 times 3 will make that a -6. Right? And I'm just going to rewrite this bottom part here. So again, these are special cases right here. That's not always going to happen. But notice that what's going to happen here is that 2x minus 2x, that's 0. That's gone. -2y plus 2y, that's 0. That's gone. Then I have -6 plus 6. That's also 0. So really what I have is 0 equal to 0. All right? That's not, it didn't all just disappear. What it is 0 equals 0. Now, only when you have 0 is equal to 0, that means you have an infinite amount of solutions. All right, so I'm just going to write infinite solutions. All right, so remember that if you were to actually solve for y here, all right, what that means is that you have exactly the same line. You have a line and you have another line that's exactly the same that's laying right on top. So we have infinite solutions. All right, so I just want to show you that. It's not always going to happen, but I'm showing you that scenario. All right, number 7. Same thing. Notice that if I add this as it is, nothing's going to cancel. But notice that I know that 3 and 6, right, if I multiply this times a 2 or times a -2, that would cancel this x. So maybe I can see that. I'm going to multiply this times a -2, so that would give me -6x plus 4y minus 36, oops, minus, let me get my trusty y dot is equal to -36, and this one right here would be 6x minus 4y is equal to 12. So notice that this one's going to be similar. Again, this is a special case. Now that's going to be canceled, that's going to be canceled. This is 0, right? So by canceling, -6x plus 6x is 0. 4y minus 4y is 0. But on this side, I don't have 0. I actually have -24. All right, so when we have something that's not true like this, what actually happened is that we have two lines that are parallel. All right, so when you have something like this that's not true, all right, when you have something that's not true like this actually means no solutions. So there's no solution, all right? Meaning, if you were to graph those two lines, there are two lines that are parallel. Remember that from the beginning? So again, there's two lines, if you were to graph and they're parallel. As opposed to this one, now this one, they're the same line. When is 0 equals 0? Always. So if it's always, it's an infinite solution. Right, on this one, that is never going to be true. So that's going to be no solution. Again, these two lines would be parallel. These two lines would be the same. Actually, it would be exactly the same line. All right. So that's that. Hopefully, you can sort of muddle through the rest. Again, I'm not going to do this one, but for example, if I'm looking at number 6, I look at the x and I look at the y. Well, there's nothing I can multiply this 3 to make it a 5 unless you want to do fractions, and I know you don't. But there's definitely something I can multiply this x to make it the opposite of this 2x, which would be a -2. All right, so if I do that, I have 2x minus 5y is equal to 20, and this would be -2x plus 6y is equal to -14. And if I add that together, notice that I would have y is equal to 6. Now this is not all the answer, but now you need to plug that back into one of these, right? So I have 2x minus 5, and instead of y, I'm going to write that 6 is equal to 20. So I have 2x minus 30 is equal to 20. Add the 30. So I get 2x is equal to 50. And if you divide both sides by 2, you get x is equal to 25. That seems very large, but let's see if we can check that out maybe. And again, if you want to check your answer, what you can do is very simply plug your answers in. So I have 2 times 25 minus 5 times 6, and that should give me a 20. Right, so I'm looking at this original function, and that does, and I have to check the other one too. So I have 25 minus 3 times y, y is 6, and that should give me a 7, and it does. So these are the answers, so I'm right. Okay. Good luck with that one. Let me go back and show you substitution. Some of you forgot how to do this. I feel like this paper is easier because normally they're giving you either the x already by itself or the y by itself. So for example, in this one, I'm going to substitute this into this x, right? Because I have x is equal to. So if I plug that back into here, I would have 2y minus 4 plus y is equal to 2. And I'm going to solve for y now. So this is 3y minus 4. Notice that I added like terms. I have 2y plus y. And then I would solve for this. Alright, so I'm going to add the 4. So that would give me a 3y is equal to 6. And if I divide both sides by 3, I get y is equal to 2. Alright, so that's honestly part of the answer. That's not all the answers. Right, if you feel like you need to write on a separate piece of paper, please do. Well, you don't have a whole lot of space here, right? So what I'm going to do now, if you remember what I told you to do 2 days ago, was that I can plug this back into, I would probably plug it back in here because there's not a whole lot of work to do. So I have 2 times 2 minus 4 is equal to x. Now, it really doesn't matter. You can plug it in here also and it would work. Alright, it would actually work. It doesn't matter. Just this one doesn't require any arithmetic. It's just adding numbers or multiplying numbers and adding. So x is equal to 0. So my answer would be, my coordinate point would be 0, 2. So remember, this is the point where these two lines intersect. Right, let's do one more. Let's quickly do one more. Number 5. If I have y is equal to x plus 2, I'm going to plug that into here. Alright, so this right here becomes, instead of x plus 3y, it'll become, excuse me, I kind of did that wrong. I'm not going to plug it into there. I'm going to plug it in. I'm going to plug it into here. Right? I'm going to plug it in for y. So, excuse me, I have x plus 3 times x plus 2 is equal to negative 2. Don't forget to distribute here, so that would be 3x. This would be 6. And then now I'm going to try to solve for x after I add like terms. So I have 4x plus 6 is equal to negative 2. Subtract 6. I know I'm going kind of fast through this, but I'll send these videos on YouTube, so if you need to look at them slowly, you can. So this is the x value. Now to figure out my y value, I need to come back over here and plug that back in. Notice that this one has x plus 2 is equal to y. This is one of the original equations. I'm going to plug that into that original equation. So I have negative 2 plus 2 equal to y. Now, oddly enough, this also gives you a 0. Yep, that also gives you a 0. So y is 0 on this one, which means your answer would be negative 2, 0. And again, you can check your answers by plugging this back in here. Alright, and I've noticed that this is true, and I noticed that that's true, but again, you may need to use the calculator to check them, alright? Again, try to do your best, and if you have any questions, you can wait for me till I come back tomorrow. Other than that, but I expect you to do a lot of this, okay?